Mike McCool here. I'm at AG Laser out in the Happy Creek Industrial Park. That's a mouthful, I'm telling you. With me is Gabriel Williams. And what we're here about today, we're going to talk about the love letters. They're great. They look really great. They were actually manufactured right here at AG Laser Technologies, right in Front Royal, Virginia. Who would have thought it? I mean,
exactly, yeah.
I remember coming out here years ago when you were still a young tyke at RMA. And your brother and your sister all went up to RMA, and your mom and dad had this place, and we talked about some things, but this has completely changed. You'd be surprised of all the things that they do here at AG Laser. But we're going to talk about love letters. So how did all this start with you?
So George McIntyre actually approached us, and he was like, Gabe, look, we're looking for someone to take on this project.
Right.
And obviously, when you're thinking about love letters, you're thinking about something that's going to be outdoor. It's going to be hit with rain, cold weather. So it needs to be rust preventative, but also withstand high winds.
Right. And not cost $1 million.
Exactly. And so we took on the project, and there were some difficulties that we faced. Is how are you going to stiffen material in the wind?
Sure.
And so through our engineering, basically we utilize the stiffening application, MIG and TIG welding, and then basically we research and develop the letters in-house, just off of the pictures.
Right. You kind of look at those things that the Virginia State Love program has.
Exactly.
We can do that, right?
Yep. And so it was really just free-handed, to be honest. So the set that's out in the Front Royal was the first set we ever made, and it turned out to be excellent for us.
Wait a minute, I see a set hanging against the wall over there.
So we also have
prototypes.
We have some prototypes. We have an aluminum set actually available that's more so for interior.
Right.
So the set in Front Royal is stainless.
Right.
So it's all stainless, 304 stainless. So it's a high grade of stainless. We also have an aluminum set, and we kind of wanted to just see how aluminum versus stainless played out in the weather. And stainless actually was a lot easier to stiffen.
Right.
And we, instead of using MIG welding, which a lot of people are familiar with, we use spot welding, which actually behind me is spot welding. We have a full spot welding line where basically two electrodes connect and create a voltage to melt the material.
Kind of cool.
Yep.
We're gonna swing the camera around here in a few minutes. They even got a robot right here.
Yep.
They got everything here. It's so cool.
Yeah.
So you started work on this thing. When did you start?
So
we know when you finished. So tell me when you started.
So we started around early November is when we basically had our drawings finished, and then we started running shakeouts in the plant in early November, and then we finished Thanksgiving week. It was pushing it close.
I remember right at the last minute.
I told George, I was like, hey, I need a little more time here and there, because every little thing from the hole size to your bend lengths, leg lengths plays a role.
The casters and that. It's because this particular set that we have now is mobile.
Yeah, we built carts with it.
Right.
Carts better than Uline makes.
The thing does look great.
Yeah.
And if you want to see it, it's down at the gazebo right now. It'll be displayed there for a little while longer. I know at least through the holidays.
Yeah.
So it is kind of cool. And you're going to give me a whole bunch of pictures, and we're going to put those pictures with the process of what they went through, and we'll put those here in the story as well.
Yep.
But tell me about some of the things that happened during the last stages.
So we had some difficulty, when you're...
He's generous.
When you're dealing with such large parts, so we have basically, we have a Midwest Finishings powder coat line. So this powder coat line is going to be running product through it constantly. It's not a batch oven where you push product in.
Right.
It's basically going to be running a line through the entire processes of cleaning, drying, powder application, and then also baking. And so when you're dealing with such large parts that you haven't done before, when they're running through the oven, you need to make sure that all of your corners are met. So the O was a bit precarious. The L, V, and E, they went perfect. It's real easy. But the O, we had to hang on a diagonal.
Make it fit through
exactly.
the thing,
and so it actually banged against our back bake oven. And I was assembling the V and the E, and I heard like it was a little noise, like it wasn't much at all.
But you knew it was wrong.
Yeah, and I went back to the oven and I saw that hanger was basically the hanger was about to pop off, and if it pops off, then it falls, and that's where you get your damage. Luckily, it didn't fall.
Start all over again.
We caught it. We drew the O back out of the paint line, but what we ended up having to do is repaint the O to get a proper bake process, send it in, then let it bake for 20 minutes so it doesn't pass through the whole entire oven.
Oh, these are different colors, like the O is red.
Yeah, and so for every single letter, we had to purge our whole painting process because red will contaminate white and black.
Oh yeah.
So we had to go from white to black to red, and each one had to be cleaned out prior to use.
It's a process. People don't realize this. Oh, we just cut that out with a laser. They have this gigantic laser.
Yep.
Great.
Yeah.
So cool. So what else is cool? Now this is a family operation. Your mom, your dad, your brother. What about that sister of yours? She's probably in the politics somewhere. I remember.
Carla handles finance.
Oh, she's here too.
Yeah.
Oh,
she assists Angie in the accounting department.
Angie's the mom.
Yep. And then Marcus, he handles sales and marketing. And I kind of.
And your dad just drinks coffee.
He helps me out. He's my assistant. Assistant plant manager. Yep.
Well, it's great. It's great. But let's just swing. I'm gonna step behind the camera here. You stay here, and maybe you can point out some things to me here. Hold on just a minute.
So we can go to this. We can go over here. Actually, we can look at this job.
Let's talk about this robot right here, because this is the coolest thing. You see these when they manufacture cars.
Yeah.
So what is this thing? It looks like a spot weld.
So this is a spot welding robot. It's not set up currently, but basically, when we have high runs of doors, we can only do 2 door variations with the robot, which is our general purpose 2 foot by 2 foot door, 24 by 24, and general purpose 12 by 12 door. And basically, it will get all of its welds within thousandths of accuracy. And the consistency of the welds is unremarkable.
So you learned to program this thing, right?
Yeah, so I can program the robot and create the jigs, but each jig has to be milled out. And the robot will it will execute as good as you will program it.
Let me pull the camera off the tripod here. Don't jerk around too much. And let's head over here and take a look at some things.
So this is basically a manual application. This is the robotic spot welder. This is a manual spot welder. And basically, you can see the operator. He's going to be putting locking mechanisms on the doors, and then putting the electrodes down to create the weld. This is actually a hotel job in New York City that's going to require at least 400 doors a week.
Wow.
In total, this is going to be at least 200 sheets of steel. Just to give you an idea, the love letter is only required around 2 sheets of steel.
And the things you do these are all totally custom and go all around the world.
Yeah, so these are all custom. You can actually find some of our products on Amazon.
Right.
Amazon will get you our doors. These go all over the world. As far as Bangladesh, we do fire extinguisher cabinets.
All from Front Royal.
All from Front Royal.
Family entrepreneurial operation. It's great.
Exactly. And a lot of our employees, we really strive to help out the community. Mm-hmm. So we deal with Blue Ridge Technical School. We also help out Warren County. They'll provide us recommendations, LFCC, because we really strive to get locals involved in the business and also grow individuals that have a wanting for manufacturing and grow their mechanical aptitude.
Well, Gabe, tell me how old you are.
21.
21. And I know you went to school with my children there, or some of them.
Yep.
Well, actually, my kids have graduated, I think, but at RMA. And I remember seeing you at LD's.
LD's, yes. Yep.
Still see you there. All right, let's head over to the laser.
Yeah. So this is kind of the #1 machine within the manufacturing plant, and we're currently doing a scrap run. So the laser processes right around 500 sheets of steel a week. Okay, and it's going to be helped by our punch as well. But we're doing a scrap run right now, so we try to operate off of 95% material usage on all of our products. So basically the requirement of all of our operators that run our cutting division is that all scrap they need to maintain, that we basically put on our big steel rack, and then we do a scrap run at some time in the week where cutting is ahead of everyone else. And so currently you can see all the scrap pieces, and I was doing a scrap run with one of my cutting operators, and he'll basically load the sheet in, and we'll get, these are all programmed, all of our engineers on staff basically translate all of our 3D drawings into a flat drawing. That flat drawing is then sent to the laser. The laser then recognizes what the actual product is, okay, and then it's going to put down a technology table that combines power, frequency, beam radius, and we'll put down, you know, thousands of degrees worth of a beam, and we'll cut, actually, it'll cut up to 1,500 inches of steel per minute.
Wow.
So it really just goes immediately through all the sheets.
We have 2 lasers at our office that'll take a 12-inch by 24-inch piece of material.
Yeah.
It's a 50-watt laser. So what do we have here?
So this is
5 megawatts, right?
Yeah, so this is a 4 kilowatt laser.
All right.
And it takes 5 by 10 sheets.
Wow.
And we'll cut all the way through inch-thick aluminum.
Wow.
And it will give, it can also be cut with nitrogen. So we've done a tremendous work for Fortune 500 companies that require a burr-free part. So we have around 11,000 gallons of liquid nitrogen on standby.
Wow.
That basically is constantly monitored. And what will happen is when our tank gets low, immediately within 48 hours, the tank is refilled. It can be refilled at 4 a.m., 2 a.m., 3 a.m. It just won't stop production. And so that liquid nitrogen really gives you a cut where you can pick up the material with your hands and it will be burr-free.
Wow. So, and all that to make love letters.
All that to make love letters.
Well, you know, I think you guys are going to be the love letter makers of the world.
We hope
here.
so. We hope so.
You know, that's a big, and other things like it. Once we get out, once it gets out there, because these kind of displays are not just love letters. They're all sorts of things.
Exactly.
That's a whole other niche. You thought you were going to make fire cabinets, didn't you?
Not at all.
So what else we got back here? You got all sorts of things.
We'll move over. So this is our troop.
Here's the boss. Well, no, this is your assistant.
My assistant.
This is Gabe's plant assistant here.
Right.
Hey, George Williams.
Yeah.
All right, you need to borrow Gabe?
Yeah.
Go ahead, Gabe. We're gonna. It looks like the assistant plant manager needs some advice from the plant manager.
Because of the wiring time.
So the next machine, so this is our True Punch 2000, and basically this is a machining application. So it will conform steel to whatever shape that you purchase within your tooling. It uses a punch and die to conform that material. So if we want to extrude any metal to a certain shape possible, that could be a catch, a lance, a bridge, such as, so this is, for instance, material you can see that was punched out and it brought out that triangle. So we'll use.
You always wondered how things like that got made, didn't you?
Exactly, and so that's how the True Punch 2000. It uses hydraulic pressure to basically create that form, and so it is also a cutting unit as well. And then from all the cut pieces, we've got flats. They're all flat, so they need to be created in a three-dimensional part, and that three-dimensional part is done here at our press brake division. So here we have an operator. He's getting ready to set up, and so he's got all this tooling. Basically, there's a punch and a die, and this is a press brake that's going to basically be applying a tonnage through the material to create a bend. And you can purchase various sets of tooling. There are millions of different tools. So he's setting up right now, and he's basically analyzed the part. He's set up his back gauges to whatever length he needs them to be to execute the bend, and then also selected the correct tooling to actually handle the tonnage.
So all these machines were used in manufacturing these letters.
Yes. Yep. So the laser, the punch, even the press brakes, spot welders or MIG welders, they were all used.
So what's the next thing for AG lasers?
To keep growing. You know, we're looking, right now we run at around 6 a.m. to 10:30 p.m. We're looking to push that to 24 hours a day, increase our second shift, run stock. We're looking to launch our products on Amazon offer a lot more SKUs.
So you're making, other than the products that the Williams brothers and the First Strike make,
Yep.
You're looking to do other things with your AG laser.
Yeah, so AG Laser handles a lot of large contract jobs. We recently competed with China, a stamping company in China.
So it must be these lasers are not on every street corner.
Exactly.
So like where are they at? Who uses these things? I guess manufacturers?
There's probably, for fiber lasers, in the state of Virginia, probably less than 10.
All set up for some specialty.
Exactly.
I know I have a specialty CD printer. I got serial number 20. So yeah, there's not many of them made.
Exactly, yep. And you know, you can have these machines, but you have to be able to accommodate them with the sales and a marketing standpoint. Because these machines are built to eat up material. They're built to run.
They don't want to be turned off. They want to run.
And so you can have the greatest machines in the world, but at the end of the day,
you got to feed them.
Someone needs to bring in the sales.
Yeah.
And luckily, we have a sales department that does that.
That's your brother.
Exactly.
So you guys keep it in the family. I mean, I think that's what you do.
Yep.
When we do that at national media as well, you know, my daughter worked there, my other daughter, my son, they've all worked there, and along with 200 other people in the community like you, we've hired a lot of local people. So what's next?
So we can actually go to our sanding division. So this is one of my favorite parts of the plant. This is our KBM stroke sander. So this machine comes from Germany, and basically
this is what makes the stainless steel look pretty?
Exactly. And this equipment gives you basically a 32-foot sanding belt.
Oh wow!
And we can apply various grains on all the material, but you can conform whatever you're sanding to the shape of the belt, or the shape of the product that you're sanding. So we can apply pressure on this belt and it won't snap. And then we have it connected to a wet dust collector that will basically separate the stainless from the steel dust. So the KBM stroke sander has allowed us to handle high production stainless jobs for as many jobs as possible, pharmaceutical companies that require stainless products, and the finish is unreal. So to give you an idea of a finished product, this is the type of finish that you're looking at. This was an extra piece, but that was ran through the sander.
And it gives you like a brushed, brushed aluminum or
brushed stainless. Yeah.
Right.
And so before is this. This is a before.
Yeah, it's just ugly.
Yep, exactly. And then we also have a MIG welding and TIG welding division, which is over in this corner. And this is where we do all of our MIG welding. We have welding curtains to, you know, provide.
This is stuff you see on the Discovery Channel.
Exactly.
Yep. So, what are we going to make next at the AG Laser? What do you think? Where do you see you going in the future? So
we're going to look to increase our product line, handle floor doors, roof hatches. You know, roof hatches is the next step in in our large fabrication division. They're heavy. They take a lot of material. The welding has to be perfect.
Precise, right.
And you know, they serve a massive purpose. When you look at all the skyscrapers in the cities, each one needs a roof hatch. Some of the roofs need multiple. So you're talking about thousands of roof hatches throughout the U.S.
It's just like that one building you said that's going to need thousands of those panels.
Exactly.
I remember the fire doors you made, the cabinets.
Yep.
It's not in these big high-rise. They need thousands of these
Yep.
things.
Exactly.
It's just amazing.
Yep.
Amazing. So you're going to squeeze love letters in?
Oh yeah, we'll always squeeze them in. We'll always squeeze them in. Yeah.
Well, we're going to look at some pictures as we go forward, and we'll wrap this thing up. But it's always great to see you.
Yep.
And your brother, Marcus, and your sister, and your mother, and your dad, and I see you have Carol working here.
And Carol, oh yeah,
she's a great graphic artist.
Yep.
She's really great. So we've got a lot of good people working here now, and I know things have changed over the last few years because you guys have completely reinvented yourself.
Yep.
It's
exactly.
Great. Well, now that you all got out of school and college and ready to go to work, and you're all ready.
All ready.
That's right.
Yep.
Well, good. Thanks again for talking to us, Gabe. I really appreciate it. Thanks again.
Thank you.